So let us discuss about modified Euler's method of solving ordinary differential equation. This method is also called as predictor-corrector method. So as usual as in the case of Euler's method, we have the same problem like this, generalization of the problem. Solve dy by dx is equal to function of x comma y. Given y of x naught is equal to y naught, that is the initial value when x is equal to x naught, y is equal to y naught. And we are asked to find the value of y at different values of x for a given increment h. So here the formula is slightly different. So the iterating procedure is slightly different than the usual Euler's formula. So first cycle, we are taking the Euler's formula equation only. So y1 is equal to y naught plus h into function of x naught comma y naught. This is nothing but your Euler's formula only, method only, which I have explained in the last video. Now from that we are going to modify or iterate the value of y1 further. So in the Euler's method we are stopping at this stage. But in modified Euler's methods, some more refinement has been given. So the first value of y1 of 1 means first value of y1 will be, we are going to take like this, y0 plus h by 2 into f of x naught y0 plus f of x naught plus h comma y1. So please note that here we are taking the average. So we are going to add these two. Instead of taking one value of function, we are taking two values of function, we are adding and dividing it by 2. That means this is nothing but the average of the two function values. One is at x naught y naught, another is at x naught plus h comma y1. So y1 we have already got here. So this gives the first approximation of y1. Next, second approximation of y1 is written as y1 of 2. Same thing, but here, see, observe here, the first term is same y0, second h by 2 is also same. Here first term is same, but the second term, instead of here y1, we are going to take this y1 of 1. Next, further, y1 of 3, third approximation of y1 value, same thing, y0 plus h by 2 into first term is same, you can see here, plus function of second term, instead of y1 of 1, we are going to take y1 of 2. This value we are going to take, that means previous value. This type the process is continued until two consecutive values. Consecutive values means, so suppose if y1 of 2 and y1 of 3, they become same, then we are going to stop at that stage. That means until two consecutive values of y are become equal, we are going to stop. At that value is taken as the y1 value. Next, suppose if he has asked one more value, y2 value, so this y1 becomes the basis for y2 value. The same formula is used for getting a y2 value. So y2 is, instead of y1 it is y2, instead of y0 it is y1 plus h into f of x1 y1. See here. So this is what x1 is nothing but your x naught plus h here. So this equation will be converted to this equation. This is Euler's equation only. This is for second cycle. For the first cycle, we are going to iterate the values till the values become equal. Same, once they become equal, that is taken as the final value of y1, and that final value of y1 is taken as the initial value for y2 for the second cycle. So here, if you observe these two equations, y1 is replaced by y2, y0 is replaced by y1 plus h is same into f of x0 is replaced by x0 plus h because it is at x1 value. Then y1, whatever we have got here, that value we have to take. Now this is the initial value for y2. Now if you want to iterate it, if you get the final value or modified value, once again just like this. Here we have written y1 of 1, y1 of 2, y1 of 3, you know. Like that you will get y2 of 1, y2 of 2, y2 of 3 like that. So till this process is continued, till the value of y2 becomes constant. So here y1 should become constant, here y2, maybe it may become constant after 2 or 3 iterations. So once the value of y2 becomes constant in consecutive calculations, we can stop at that stage. So that is the value of y2. So like this the process is repeated till the last value of y is obtained. Sometimes you may be asked to find y3, y4 like that. So it's an iterative procedure. So once the final value is reached, you can stop at this stage. And normally they will ask you to find to 3 decimal or 4 decimal places. So let me take a problem now of this modified Euler's method. Problem using modified Euler's method. Using modified Euler's method. Find y when x is equal to 0.1, 0.2. Given dy by dx is equal to, this is the equation, x plus y. Y of 0 is equal to 1. This is the equation. Okay. Now let us see how we can solve this by modified Euler's method. In the exam they may ask both the methods. Same problem they ask, but they have to give 10 to 12 marks. So here let us solve this by modified Euler's method. This is the equation. What is the function here? F of xy is x plus, okay, and x naught is 0, y naught is 1. This is it. So now this is the given equation. Now let us see, first approximation is this. And what is the value of h here? So h I will take as 0.1. I will take h as, so take h is equal to 1. That means you have to do 2 steps. So first and second. 0.1 and 0.1. So h is 0.1 here. Now first let us take this first cycle. The first cycle we are finding y1. So y1 is equal to, let us write that y0 plus h into f of x0 comma y0. This is your regular Euler's equation. Now let us substitute. So y0 is 1 here plus h is 0.1 into function of x0 comma y0 means f of x0 is 0, y0 is 1. So 1 plus 0.1 into here f of 0 comma 1 means this is x, this is y. Function is x plus y. Therefore this is 0 plus 1. So I think it is 1 point. What is the answer? 1.1. 1 plus 0.1, 1.1. So this is this value, y1 value. Now we have to modify this value using cycles. So y1 of 1 I will write. How to get to y1 of 1? Y1 of 1 is y0 plus x by 2 into f of, I write it, x0 comma y0 plus f of x0 plus h comma y1. Okay, now let us substitute these things here. Y0 here is 1 plus h is 0.1 divided by 2 into f of x0 comma y0. So f of x0 comma y0 means f of 0 comma 1 plus f of x0 plus h means 0 plus 0.1, that is 0.1. y1 is this value, 1.1. Okay. Now let us substitute 1 plus 0.1 by 2 is 0.05 multiplied by f of 0 comma 1. This is the function. So x is 0, y is 1. Therefore this is 0 plus 1, which is 1 itself. Plus this is f of x comma y means 0.1 plus 1.1, which is 1.2. Correct? X plus y. So now we have to simplify this. So what is the value? 1 plus 0.05 into 2.2. Just take the value. 0.05 into 2.2 plus 1. 1.11. 0, 0, 1, 1, 0. Then we will go to second this thing. y1 of 2. y1 of 2 we have, right? Second iteration. So y1 of 2 is same. See here, y0 plus h by 2. y naught plus h by 2 into f of x naught comma y naught plus f of, here what is the change? X naught plus h, but here y1 of 1 we have to take. Instead of y1 we have to take y1 of 1. Got it? Now y naught is 1 plus 0.1 by 2, h is 0.1 into f of, it is same. So f of x naught comma y naught means f of 0 comma 1 plus f of x naught plus h is once again it is 0.1, x naught is 0, h is 0.1 comma y naught of 1, 1.11 like this. Now this is 1 plus 0.05 by 2, 0.05 into this is 0 plus 1, it is 1 plus this is 0.1 plus 1.01 means 1.21. Right now? Is it okay? 1.21. Now if you simplify this, what is the value? This is your second value. 2.21 into 0.05 plus 1.
1.1105.
1.1105. Now let us see one more. y1 of 3. y1 of 3 is y naught plus h by 2 into f of x naught comma y naught, that remains same, plus f of x naught plus h. Instead of y1 dash y1 2 you will get y1 instead of y1 1 we have to write y1 of 2. So that is 1 plus 0.1 by 2 into this is same, this first value is same, 1 only, plus here second value is f of x naught plus, okay, you write f of 0 comma 1 plus f of 0.1 comma this value we have to take 1.1105. Now if you simplify this, 1 plus 0.05 into this is 1 only plus this is we have to add this to 1.2105. Now just simplify this. 2.2105 into this plus 1.
1.1105.
1.11
0525.
05. Now you can stop. If these two values are equal, you know. So this is your final value. Therefore, what is the value of y1? y1 means the value of y at the point 1. That is equal to 0.1. It is 1.1105. Because the two values become equal, so you can stop at this stage. Now, he has asked the value of y at x is equal to 0.2 also. Now, what you have to do is, we have to proceed further like this second equation. y2 is equal to y1 plus h into f of x naught plus h comma y1. Like that we have to go. Now, let us see how we are going to get the second value. Second cycle. So for the second cycle, to find value of 0.2. So I will write this equation: y2 is equal to y1 plus h into f of x naught plus h comma y1. Yes, this is the equation, highest equation. So now y1 we have to take this value 1.1105 plus h is 0.1 into function of x naught plus h. X naught is 0, h is 0.1. Therefore, this becomes 0.1 comma y1 is once again 1.1105. Now this becomes 1.1105 plus 0.1 into this plus x plus y. Function is x plus y. Just we have to add these two. 1.2105. Now just simplify this. This is the initial value of y. The first value of y. Then we have to iterate.
1.2315.
1.23155. Okay. Next we need to iterate this. So iteration means we have to write this y2 1. You have to improve the value. So y2 of 1 will be equal to y1 plus h by 2 into f of x naught plus h comma y1 plus f of x naught plus 2h comma y2. Yes. Now this is y1, we have got that value 1.1105 plus h is 0.1 by 2 into f of x naught plus h is 0.1, correct? 0 plus 0.1. y1 value what we have got there, that one 1.1105 plus function of x naught plus 2h, x naught is 0, 2 into 0.1, that is 0.2, comma, y2 value this value, 1.2315. Now let us substitute and simplify. 1.1105 plus this is something about 0.05 into, here we will take this plus this, x plus y is the function, so 1.2105 plus here also x plus y is the function, so 1.4315. Now simplify this. This is the first approximation of y2. One point two four two six zero. Now second approximation, y2 of 2. Similar to the first one, what we have to write, y2 of 2, have to write y1 plus h by 2 into first term remains same here, correct? First term remains same, x naught plus h comma y1 plus second term will change, f of x naught plus 2h here. Instead of y2 we have to take y2 of 1. Got it? Huh? Now we substitute. So y1 is 1.1105 plus 0.1 into f of x naught plus h is 0.1. y1 is how much we got? y1 1.1105 plus function of x naught plus 2h is 0.2, comma y2 of 1 is this value 1.2426. Okay. Now simplify this. How much you get? So this is 1.1105 plus 0.05 into, this is x plus y, that is 1.2105 plus this plus this 1.4426. Now this is the second approximation of y2. Simplify it.
1.243155.
1.243155. Okay. Next, we will go to third approximation. y2 of 3. y2 of 3 is, see here it is y1 plus h by 2 into the first term remains same, f of x naught plus h comma y1. Second term will change, f of x naught plus 2h. Instead of y2 of 1, we have to take y2 of 2. Like this. Yes. Now here if we substitute 1.1105 plus 0.1 by 2 into function of x naught plus h is 0.1. Y1 is 1.1105 plus function of 0.2, comma y2 of 2 is this 1.243125. Okay. Now we simplify this. 1.1105 plus 0.05 into x plus y is 1.2105 plus here also expressed by 1.443155.
One point two four three one
1.24
three one eight
3182.
8 two.
318. Mostly next it will. Okay, you can stop here because if you see here, the value of this is. If you round it up, this can be as 1.2432. Correct? This is also 1.2432. Okay. 4 digits. So this is the final value. So this and this they are equal. I have rounded out 4 digits. So therefore the value of y2, that means the value of y at x is equal to 0.2 is 1.243. So we have got y1 as how much we have got? The value of y at x is equal to 0.1 is 1.110. These two are the answers. So this is modified Euler's method. Usually 2-3 iterations it will stop, it will become equal. So this is how we have to do. Now usually they will give simple algebraic expression like this. Whatever will be the function, procedure remains same. They may give exponential or logarithmic, whatever they may give. So the same procedure is followed. I have taken up to 4 digits. So this is more accurate than Euler's method.